Hey kids, I want to continue where we left off before break with these higher order differential equations, homogeneous still, equal to zero. And I gave you, right, just extensions of what we had done in chapter 3, where, okay, so I need to find the characteristic equation, turn it into a polynomial and solve that polynomial. It was just more annoying when we got a third degree, fourth degree, blah, 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 blah. But I gave you what happens when you have a repeated root, what happens when you have a repeated complex root. But I didn't go into the scenario where you have to find the complex roots on your own, right? When you can't do it by the algebraic means that you found so far. So for instance, if you look back at your notes and one of the examples that I gave you, one of the last examples we did before the break was I said, oh, here's this fourth degree thing with a characteristic equation with these repeated complex roots or non-real roots. So I wanted to take you through this example where I don't need anything fancy. I can just write, this is the characteristic equation here is in purple. And when I look for 3 roots, right? I'm looking for 3 solutions or 3 roots. Since this is a cube, I know what one of my roots is. I know the one real root is -2, right? I take the cube root or raise -8 to the 1/3. So no big deal. I can find the other ones. I know I have -2 and 2 non-real roots. How do I find them? Right? I just use division in the quadratic formula. No worries. Right? So do you remember what that scenario would be? Here's my -2. If I use synthetic division, I'm going to use my 1, the coefficient of the cubic, the coefficient of the squared, the coefficient of the linear, and the constant. And I'm dividing by a 0, so I should get a remainder of 0. And what I'm left with, I've depressed to a quadratic. So this is r squared minus 2r plus 4. I can just use the quadratic formula on that. 2 plus or minus the square root of 4 minus 4 times a times c all over 2, which is 2 plus or minus the square root of, what is that? 4 minus 16, -12. So that's 2i root 3 all over 2, aka 1 plus or minus I root 3. Why did we care about that? Well, because we needed our 3 zeros to write our solution. Oh, I think I typed this out, but you know what I mean, right? I use my real one, and then I use where I have my A and my B. So I have e to the 1x. Right? But to find these, I was able to just use division. But I didn't have to. I could have used DeMoivre, which I feel like is a really bad picture of him. I really couldn't find a great picture of him. But thanks, DeMoivre. You're very sweet and you're very nice to offer to help, but I didn't need you here. I had some non-real zeros, but I knew how to find them using division. The question becomes, what happens when that doesn't work? So if I do need DeMoivre, I have to remember the polar form here, right? And probably you saw this in pre-cal, right? The polar form of a complex number where r, and it's a little unfortunate that we use r here. Remember, r is for radius, right? This is the radius, and this is theta. When you're in polar form, r is Pythagoras, hello. And theta is the inverse tangent of b over a. And don't forget, you have to think about the signs of b and a so you can determine what quadrant theta should be in. And then we can find the distinct roots of a complex number raised to a power. So think about what I was trying to do. I was trying to solve the equation where I had r cubed, different r, a little bit of a dagger, r cubed is equal to -8, right? So I was taking -8 to the 1/3 power. So I want you to look at this here. I can find the distinct roots of a plus bi to the 1 over p. This is called, do you remember cis? This is r cis theta. So for us, it's going to be the radius from polar raised to the 1 divided by p, which are the distinct roots I'm looking for. Cis, which is cosine plus I sine of theta. Theta plus, though, here's how I get my repeated roots. I'm going to add 2 pi, multiples of 2 pi, where n is however many roots I'm trying to find, 0, 1, 2, up to p minus 1. So if you're trying to find 3 roots, right, I need 0, 1, and 2. If you're trying to find 7 roots, you need 0, 1, 2, 3, 4, 5, and 6 would be your n's. So let's try this with where we didn't really need DeMoivre. So here I am back figuring out that I have r cubed is equal to -8. I rewrote -8 as a non-real number with a real and a non-real part. Then I used the polar r to find the radius, right? This is my a and this is my b. So the square root of a squared plus b squared is just 8. And then inverse tangent of 0 over -8. That's on the negative x-axis, right? So that inverse tangent is pi. And n, the number of roots, the 0, 1, and 2, right? Because what's p for us? There's p. So finding my distinct roots of this r cubed is equal to -8 is you take the -8 to the 1/3 power, right? But just take -8 in polar form, right? Or in complex form, I should say, right? Because to solve this, you're going to take -8 to the 1/3 power. So here is my number that I want to raise to the 1/3 power. I'm looking for these 3 roots where n is 0, 1, and 2. So what am I going to fill in here? This is, this is the r that I got from the radius. Square root of a squared plus b squared raised to the 1 over p is equal to cosine of pi. Where did the pi come from? That's where the pi came from. So cosine pi plus I sine of pi. But in order to find all 3 roots, I have to plug in a 0. And what do you get out of that? Excuse me. 8 to the 1/3 is 2. Cosine of pi over 3. What's cosine of pi over 3? Plus I sine of pi over 3. Next, fill in a 1. So what is this? This is cosine of 2 pi plus pi, which is cosine of just pi. What's cosine of pi? And don't forget you have the 2 out front. -1 plus I sine of pi, which is 0. Next, fill in the 2. So this is cosine of 5 pi over 3, all times this 2 out front. Cosine of 5 pi over 3. and sine of 5 over, right? 5 pi over 3 is in quadrant what? Quadrant 4. So the cosine is positive, but the sine is negative. So what do I end up getting out of this? So my distinct roots that I was looking for of my characteristic equation is 1 plus I root 3 and negative 2 and 1 minus I root 3. Hi, that looks familiar, right? What did we do with these roots? We used them to make the, right, to create the equation. This was the real root. Ah, right, so there's my negative 2. Here's my 1 and my cosine of root 3 and sine of root 3. So I got the same answer. So it was very nice, DeMoivre. That was an awful lot of work, though, for me to get something, these two non-real answers that I could get with just a simple division. So what happens when I give you a problem where you can't do that? So check this one out. I think I mentioned this before, but I can't remember. Right, when these parentheses are around there, that you're to assume that's not y to the fourth, that's the fourth derivative. So my characteristic equation here is r to the fourth plus r. I'm sorry, plus 1. So I'm looking for all the roots of r to the fourth plus 1, of which none of are real, right? Can you picture that? R to the fourth plus 1 is above the x-axis. None of these are real. So I want to take r to the 1/4 power is equal to negative 1 to the 1/4 power. I'm going to write this as, right, I'm going to take my negative 1 and I'm going to put it in my complex form. And I'm going to get negative 1 plus 0i to the 1/4. So using DeMoivre, what's my p? 4, right? I'm looking for 4 roots. What is n then? Good. What is my polar r? My radius? Just 1. And what is theta? Pi, right? So with all of that information, I'm going to be able to say that r, the blue r that I'm looking for, is equal to the red r raised to the 1 over p, which is just 1, cis pi plus 2n pi over what? What goes in this denominator? P. So all I have to do is replace this n with 0, 1, 2, 3, and 4. 1 to the 1/4 is just 1. So I'm going to get 1 times cis pi over 4. 1 cis 3 pi over 4. 1 cis 5 pi over 4. And 1 cis 7 pi over 4. Right? When n was 0, 1, 2, and 3. So cosine I sine theta when theta is pi over 4. And again, I'm really multiplying by 1. Don't forget that. I mean, it's very nice to drop it. We can really drop it in this case. Just don't forget it when I don't have a 1 there. So cosine I sine theta with pi over 4 is 1 over root 2. When it's 3 pi over 4, cosine is negative, but sine is positive. 5 pi over 4, both cosine and sine are negative. And 7 pi over 4, cosine is positive, but sine is negative. Do you see your conjugate pairs here? Right? 1/2 plus I 1 over root 2. Ah. Oh, I forgot my root on that one. And negative 1 over root 2, plus or minus. Right? 4 distinct roots that I get using DeMoivre. Thank you very much. Oh, wait, I'm not done. What am I trying to do here? I'm trying to write a solution. So what does my solution look like? I firstly have I don't have any real, right, components, so I just have e to the what? 1 over root 2 x. Could have put my x up here, couldn't I? Would have made it a little nicer. Plus e to the who? Negative x over root 2. Right? Okay, so nothing, right, mind-blowing, different about the differential equations part. It was just how I had to solve my characteristic equation. Okay. All right. So next we will move on to solving these higher order non-homogeneous differential equations. All right. I will see you in our next live session.